Hello everyone, I hope you all are doing great. So today we will try to understand how we find patterns and how we print series. So here we have a series, okay? And we need to find a pattern in it. So let's start. First we will look into the first column, okay? We see that here is 2, 3, 5, 7. By this we can predict that the next element will be 11, then 13, 17 and so on. So what are these? These are prime numbers. Now let's look into the left column. Okay, we know that this pattern is prime numbers, okay, a series of prime numbers, but what is this? So let's check the first row. We have a prime number 2 and it is associated with a number 2. We can't find a pattern with just first row. Let's look into the second one. Here we have 3 as prime number and it is associated with 5. Here we can see a pattern. Here 2 plus 3 gives us 5, right? We are not sure though, but still here is a chance that this can be our pattern. Let's look further. Here 5 plus 5 is giving us 10. So this is the pattern we need. Okay. Here also we can see 10 plus 7 gives us 17. Okay. So what is this? This side is a series of prime numbers, right? And this side is the sum of those prime numbers. Okay, let us see how we can code this. We see that first row is 2. It's 2 and it is associated with 2. Okay, so we can say that it was added to 0, that's why we got this 2, and then this 2 comes here and this was added to this, then after we got this 5 it was again added to this. Okay, so our first sum will be 0, we know this. Let's say our sum is n and it is set to 0, and then we have another prime number. We have another variable which stores prime numbers. Okay, so what we are doing is we can see first we are adding n, okay, and then we are adding a prime number. First we are adding n, then we are adding a prime number, and it is equal to n again, right? It is equal to n again. So our first step is this, and we have n equals to 0 and I equals to 2, which gives us n equals to 2. Our second step will be our n will be 2 this time, and our prime number, next prime number will be 3, which gives us 5. Similarly, our third step will be our n is 5, our prime number is 5, and our result is 10. So we know we have decoded our pattern. Now let's see how we can code this. So this is the code I have written. Here I have initialized a variable n. We saw this earlier and it is set to 0. Okay, then we have initialized a for loop, okay, where I goes from 2 to 20. This 20 is because I want a series from 2 up to 19. You can set this to any number n or num. Okay, now why we are taking it from 2? Because 2 is our first prime number. It is unnecessary to initialize it from 0 or 1. Okay, we have started with 2. Okay, but why we are taking these numbers? Because this will be checked by some method we are going to check each number if it's prime or not. Okay, how we are going to check it? First, I have initialized a variable called prime and I have set it to true, and then I have initialized another for loop where j is going from 2 to int of square root of I plus 1. Now what is this? What is this? Let's look into it. I have written int of square root of I. Why I have written this? Before understanding this, we need to understand how we check prime numbers. Okay, so our first approach is, suppose we have a number n. Okay, this can be equal to anything, let's say 65. Our first intuition will be to divide it by every number from 2 to 64, right? Our first intuition is this, that if we try to divide it with every number, okay, and if it leaves a remainder 0, which means that it was divided by any of them, and it leaves remainder 0, that means this number is not a prime number, right? It is not a prime number. But if we can't divide it by any of the number and the result was the remainder, the result was not equal to 0, that means it was a prime number. It's not a prime number, it's a prime number, right? We can see it's a very lengthy process, okay, because we are dividing it with every number from 2 to n minus 1, right? If suppose the number was n, we are dividing it with every number from 2 up to n minus 1. If n is a very big number, suppose this, then we are going to divide it by 2, 3, 4 up to this number. And you know, it's a very big number. It's going to take a lot of time. It's very time consuming. Okay, so it's not the optimum approach. What can be the optimum approach? Let's look into that. Our second approach will be going halfway. Okay, if n is the number, we are going to go halfway. Okay, we will only take the integer part, or we can also write it like this. Okay, we are going to go halfway. Suppose we have a number 65 again. What we will do is we will divide it by 2, 3, 4 up to 32 only. But why we are not going after 32? Why not 33? Let's see. What can be the lowest number by which it can be multiplied? Lowest integer, okay? We know it's 1, but it gives us 33 only, so it's of no use. What is the next lowest number? It's 2, and you know 33 into 2 is 65, which is already greater than 65. So no way this number is going to divide 63. Similarly, 34 into 2 will be again greater, right? That's why we are going only halfway. We are going halfway, which reduces our time by half. If in first case it takes 100 seconds to execute our code, in this case it will take only 50 seconds, right? But still, it's not the optimum approach. Let's finally look into the optimum approach. So our third case will be going up to square root of n. Okay, now we have to understand this. Please see carefully. Suppose we have a number 97. Okay, let's find its square root. We know 9 square is 81, and 10 square is 100. Okay, this means that 97 is going to lie between 9 and 10. This can be 9 point something, right? But we are taking only the integer value, that's why this value will be 9, which means to check if 97 is prime or not, we are going to divide it by 2, 3, 4 up to 9 only. But why we are not going after 9? From here we are going to get encountered with two numbers, composite and prime. Since composite numbers have factors which we have already checked, suppose the next composite number is 10, right? It's 10. We know its factors are 2 and 5, and we have already checked with it. Next prime number can be 12, which is 3 into 2 into 2, and we have already checked with it also. So our next case is prime numbers. What if we encountered a prime number? There is a high chance that that prime number can divide 97. But why we are not checking with it? Let's take the very next prime number after 9, which is 11. Okay, let's see why we are not trying to divide it with it. We know 11 into 2 is 22. Right now we know that 11 doesn't divide 97. It doesn't divide it. Okay, so we know it doesn't divide it, and we have checked with 2. So 22 can't divide this number. Similarly 3, 4. Okay, these number can't divide it. Okay, and after we reach some value, say 9, okay, 11 into 9, we know that we have checked with it and it doesn't divide this number. But 11 into 9 is already 99, which is greater than 97, right? So no way this prime number is going to divide 97, and any number greater than 9 will not divide 97, because we have already checked it till root 97. It's unnecessary to divide after it. If you didn't understand this way, let me try to explain it with a different approach. We know our square root was 9. The integer value was 9. Okay. Suppose we go up to 9 into 9. Okay. It was 81. We checked it. We checked these numbers. We can't divide it by it. Right. And we then go 9 to 10. 90. Okay. We have checked with this, but we haven't checked with 10. But we have checked with its factor, and 90 doesn't divide 97, and it's already greater than halfway, right? It's greater than halfway, so it won't divide this number anyway. But if we get a prime number, then this will be 99, which is again greater than 97. So it's of no use. It's no way this number is going to divide 97. So that's why it's unnecessary to go after square root of n. Now we understood the purpose of this clause, right? And plus 1 just to include this case. We are not going to exclude this case. We have to include this. Okay. Now what will happen? We will go into this loop and we'll check the number bought by this I. Suppose a number was 5. Okay, the number was 5, and it will be checked by j. If it leaves remainder 0, then it's not a prime number. We will set the variable prime to false, right? And this will continue. But if we encounter with a number which doesn't satisfy this condition, then this variable will remain true. Okay, and if it remains true, we'll go in this if clause, right? What is this? If prime, or we can say if true, then do this. What is this? We know this can be written as n plus I. We saw this earlier. We will do this, and after this we will print this line. Here I have used f string, and then I am printing prime number, our prime number, and then we are printing the sum. So now let's look into the code and try to run it. So here is our code. Let's run it. We can see we have got our correct pattern. I hope you enjoyed this video and learned something from it. Remember to keep practicing, and I'll see you in the next one.